The names of 4 particles are listed below: alpha, beta plus, neutron, proton. State the name or names of the particles in this list that are not fundamental. Alpha, neutron, proton. There we go. Those are not fundamental particles. They're made up of other things that do not experience an electric force when situated in an electric field. Neutron. These things are charged. Alpha, beta plus, proton, all charged, and therefore will feel a force in electric field. The neutron won't, right? It's neutral, so it's not charged, no force in an electric field. Has the largest ratio of charge to mass. Charge to mass ratio. So this thing is the most massive. Its charge is like 2e over 4u. This one is positive 1e over basically nothing, 0.0005u. So that's probably the winner right there, right? Because it wants the largest ratio of charge to mass. So that we're dividing by such a small mass, that's got to be it, right? Like it's got to be beta plus. Come on, we don't even need to consider the neutron and the proton. They would be, so this one would be 0, right? The charge to the mass would be 1 unified atomic mass unit. So the ratio there is 0. And this one would be positive 1e over 1u. Okay. So yeah, you can, just because this mass is basically 0, it has the largest ratio of charge to mass. We're dividing by a tiny, tiny mass. A hadron has a hadron has a charge of positive e, where e is the elementary charge. The hadron is composed of only 2 quarks. One of these quarks is an anti-down quark. By considering charge, state and explain the name or the flavor of the other quark. Okay, it has a charge of positive e. It's composed of 2 quarks, and one is an anti-down. So a down quark has a charge of negative 1/3. So the anti-down is going to have a charge of positive 1/3. It has the same mass, but it has the opposite charge. And so it would have to, if it's positive e, what does it need? It needs a charge of positive 2/3. Well, what's a quark that has a positive 2/3? It could be an up quark, but that's not the only quark. That has a charge of positive 2/3, right? It could be a charm quark, or it could be a top quark. So I don't know if they would accept any one of those answers, or it's expecting you to sort of say, well, it's got to be an up quark. That's the more typical one. Okay, so it could be an up and an anti-down. Is anti-down up? No. So I would go with the up quark there. If you add an up quark to an anti-down, you'd have positive 3/3 or positive 1. In the next couple moments here, I'm going to queue up the mark scheme so we can give ourselves some feedback on that. Other quark is an up. Okay. But I wonder if you said, oh, it's a charm quark, right? Because a charm quark also has a charge of positive 2/3.
Like, wouldn't they be like, to have to like communicate with each other and be like, well, what
yeah, if they agreed, say, well, some students that have put top or charm quark, that's technically correct. They probably say, well, we'll accept it, but let's not write it down in the mark scheme. Well, let's get students thinking about sort of the typical particle, right? And so charm quarks and top quarks, the other flavors are unstable and they decay. They don't really exist in nature for very long, right? Long enough for us to detect them to know they exist, sort of particle detectors. I think everything else there agrees, right? Alpha, neutron, proton, neutron, beta plus, the anti-down is a charge. Yeah, so it's all there. Well done. We did another one from this paper, right? We did the momentum one. So let's check those answers while we're at it. And there you can see 4 kilograms, 3.2 meters per second, 97 joules. There you go.